Hi. Hi, good happy Friday, and welcome to. Hold on 1 second. Let me set up my audio. Okay. Uh, good afternoon, everyone, and welcome to TGI Pulsar. It's a weekly live stream about Pulsar and its ecosystem, and it's organized by StreamNative. My name is CJ, and I am the co-founder and CEO of StreamNative. And StreamNative is a company that offer managed Pulsar, and we contribute a lot to like Pulsar and helping growing the community of Pulsar. And I'm also one of the PMC member of Pulsar, and as well as PMC chair for Apache Bookkeeper. So TGI Pulsar is a kind of a weekly live stream for Pulsar, and we will be talking about Pulsar in its ecosystem and continuing our kind of uh, continuing on the last episode. We kind of talk a bit about the Pulsar schema. And in this episode, I'm going to kind of talk more about Pulsar schema, and it's very important to understanding Pulsar schema in order to understand Presto integration, Flink integration, and Spark integration. In Pulsar, we treat schema as kind of the first class citizen. So we kind of do a lot of work on enhancing schema. In one of our webinar that last week, we invite uh, CVG from Nutanix talking about the use cases and also the experience on using Pulsar in production. And one of the kind of pattern they're using is about event sourcing. And when you using event sourcing, I think schema and especially allow um, multiple type of schema within a single topic is very important. So with that being said, if you are using Pulsar for data processing, event streaming, event sourcing, bunch of things, schema is kind of one of the first thing you should looking into when you want to building out those applications. So back to kind of the episode we are going to talk about today. As usual, we'll start from week in review. And in this week in review, we kind of want to share. I want to share a few things. That is, 2.6.0 is coming, and I think Peng Hui, who is the release manager for 2.6.0, is already kind of working on cleaning up bunch of the uh, GitHub issues, pull requests to finalize the 2.6 release. And it's the first release candidate is probably will be coming out over the weekend, maybe on Monday. But it would depends on the progress on merging those PRs. So stay tuned. It's coming. Uh, the second thing is the bunch of a lot of the pull requests coming in the post GitHub issues. So a lot of interesting things happening, and one of the kind of most interesting thing, I mean, I am particularly interested in is broker interceptor. Uh, there are kind of two efforts going on here. Is one effort is coming from Peng Hui, and the other effort is from Matteo. But they are kind of doing similar thing, but there's some overlap. Uh, I'll probably start with the Matteo's pull request, it try to kind of introducing an interceptor interface in the broker side, and that is allowing you plug in different implementation to trace in kind of reject any operations happening in the broker side. Mostly the current implementation is around the admin RESTful API. So if you want to trace, if you want to kind of manage the behavior for kind of the admin operations, you can add interceptor interface. And the other one that Penghui does is more focusing on the kind of connection level. It's more focusing on binary protocol level. Is he introducing this broker interceptor to kind of intercepting the connections that connect to the brokers. And I think we are talking about kind of combine these together into a broker interceptor framework. So everyone can write a broker side interceptor just as what you can write a client side interceptor to intercepting any connections, operations that are happening within Pulsar. And that is very useful, especially if you want to build out your tracing framework to trace the message, how the message is flowing from your producer to broker to bookies and all the way to the consumers. So those interceptor would allow you to integrating your Pulsar cluster with tracing framework. Either you already have a tracing system, you are going to building a tracing system using interceptor is very useful. And other use cases, you can also using interceptor to kind of maybe add enhancing some of the operations. Want to want to enforce some of the quota limitation. Those could be done with this broker interceptor interface. So I think it's a great features that going to be added into the Pulsar and the core Pulsar system. So this is the kind of the features. So stay tuned. 2.6.0 is coming, and we as you if you have listened to check out the weekly Pulsar TGIP weekly live stream, you probably already know we are going to have a Pulsar Summit in about 2 weeks. Features about like 30 plus like sessions from different companies, and along with the Pulsar Summit, as it probably just show Pulsar Summit website, uh, you've been noticing there's a kind of Pulsar training. It's a 4-day training. It's actually not full day. It's a 4 half-day training. The training is led by JC Anderson. JC is one of the kind of Pulsar experts. I would say in general, big data experts. He teach a lot on the big data softwares like from Hadoop to Kafka, now Pulsar, and as well as Flink. He has very deep knowledge is around the whole Pulsar and as well as the ecosystem. And the training here is it's about like developing Pulsar applications, and it will cover like how to use Pulsar's PubSub API to develop a producer in consumer applications, and as well as it would also looking into this Pulsar ecosystem, including Pulsar functions, how you can use, how you can develop a function using Pulsar functions, and the as well as the Pulsar IO, Pulsar SQL he will cover different components in the Pulsar ecosystem, and we kind of offer that in a very low chip rate, and and also the space is limited. If you are interested in learning more about Pulsar and how to develop an application using Pulsar, definitely check out this uh, training session. And I will also be hanging around with JC in a training, but most of the time JC will be leading the whole training session. I'll be just there to hang out with you guys. So this is about what was happening in this week. Uh, so I'm going to kind of continue the conversation on the Pulsar schema from last week, and that we're going a bit deep dive into how schema work and schema the including the schema compatibility check, and when you are using different type of schema compatibility strategy, what is the order of upgrading client, and within the schema compatibility check you need to consider about the transitive and non-transitive backward and forward compatibility, and how does Pulsar achieve multi-versioning on schemas. And once you have a concrete idea about how this workflow works, then I will use that kind of introduce Presto circle, and mainly I'll cover three questions. And these three questions I think are important to for people to understand how Presto Circle works. So the first thing is how we convert a topic into table, and basically how we map these concepts between Pulsar and Presto, and how we convert messages into rows within a table, and how does Presto queries the event within Pulsar. So that is kind of the overview about what I'm going to talk today. I will start kind of with kind of a short presentation that is covering some of the concepts. So as we mentioned in kind of our last episode is Pulsar, each topic would associate with a schema, and the schema is defined by schema information. And within the schema information, you have the type, the schema data, which is the specification, and properties. So those are kind of formed as a schema information. And how does this schema information is being used by Pulsar? It's actually used by on kind of the connection level. Uh, with that being said, is the schema is kind of uploaded or retrieved when you create a producer and consumer. But for sure, you can use schema tools to update schema. But for your application to interact with this schema information, what you do is like from a producer and a consumer. And in last episode, we kind of show how you can program your producer and consumer on writing this data structures using schema. So continue the conversation here is I would like to explain a bit how does it work when you create a producer. And so like from applications, this is a diagram is kind of showing the whole workflow, how a producer would interact with broker like with using schema. So first thing is on the application side, uh, sorry. On the application side, you need to kind of specify a schema. That schema can be created from a module, It can be created from a generic schema builder. And once you have the schema, you will pass in the schema to Pulsar client to create a producer. And under the hood is uh, Pulsar client library would extract the schema information from a POJO. So it would get the schema information, and the schema information would include the type, which could be Avro, and the schema data, which is the schema specification, which means that what is the structure, what are the fields. And once you get the schema information, Pulsar, the first command that Pulsar sent to broker is called connect command. And Pulsar client would put the schema information into this connect command, and it will send the schema information to the broker. Once broker receive the schema information, it would do it would do a couple of things. The first thing it would do is check if the schema is already registered or not. If there's already a schema registered with this topic, then it will skip this schema, skip registering this schema. And since it's already registered, then it would get the schema version, and it would send the schema version back to the producer. So producer would get a schema version, and any master produced by this producer would be attached with a schema information, with schema version. So that means every masters that produced by this producer will contain the schema version, and that version can be reused by the consumer to figure out what exactly the schema is the consumer need to retrieve in order to deserialize that mastery. So that is the kind of the a simple flow. And broker, as you can see here, broker would check the schema. If the schema doesn't exist, it would go check. It will try to try. It will go through the process of registering or add this schema to this topic. And adding the schema would involve an operation called check compatibility. So it would compare the schema with any schema existing in the topic to see if the schema is compatible with the other schema or not. And if it's compatible, it would just store the schema and return the schema version and send the schema version back to the producer, so producer can use this schema. But if this schema is incompatible, that means you are not able, it's not compatible. It means you should not, broker should not add this schema to this topic. Then broker will just reject this producer. By rejecting the producer, it basically disconnect the connection, and you will receive exception at the producer side saying schema incompatible, something like that. I don't remember exactly uh, exception master, but you should receive a schema related exceptions telling you you are using an incompatible schema. So that is the producer flow. And I want to kind of stop a bit here is as you can see here, the schema information is only sent once. Is only sent like during when producer create the connection to a broker. The reason why is the kind of the networking model uh, in Pulsar is producer would maintain a persistent connection with the broker. So once you kind of connect, you just need to kind of verify the schema once. Once the schema verified, then the producer will get a schema version, and it can continues use this schema version for producing the messages. And on the producer side, since you already have the type information and also the schema, so the producer would just serialize and deserialize based on the type information, and that would convert the structure into bytes array, and producer associate with the schema version with the bytes array and send the whole message back to the broker. So you don't need to send schema information along with individual messages. So this will save the whole network bandwidth, and you just need use the schema version to tag individual messages, and that is kind of the whole design for the producer side. Sorry, for Pulsar schema. And uh, after kind of knowing a bit about how a producer works, then let's take a look at how consumer works. So as you probably already noticed, is the diagram is almost same. I just changed the uh, producer to consumer. That means I think the workflow is exactly same. Is still like when consumer want to consume a message, it will pass in through it will pass the schema information to the broker, and broker will still kind of check the schema information. For consumption, most of the time, uh, broker would just check the schema information to see if it's compatible or not. And if it's compatible, it will just return kind of the schema information back to the consumer. But sometimes you also need to kind of it would also trigger some the schema uh, trigger broker adding schema. Why? Is because in Pulsar there's a concept called auto topic creation. So usually consumer would automatically trigger a creation of the topics. So if if auto topic creation exists, and if the topic doesn't exist, and consumer connect with a schema, and this would trigger broker create a topic and as well as register the consumer schema as the topic schema. So that is the kind of the way you can see here is in the right side of the diagram. That is the only case when consumer connected to broker, it will trigger broker add a schema. It's only when topic does not exist and broker enable topic creation. Otherwise, the consumer would just go through the kind of the left side logic is it just check the if the schema exists and compare if the schema is comparable or not. But it doesn't for any future schema. It does not add a new schema to the topic. So this is on the consumer side, and the workflow is very similar. So in this producer and consumer workflow, there's one important thing here is the check the compatibility. And this is done by kind of schema compatibility checker. And the checker is actually one checker per schema type. And it's configured by these schema registry compatibility checkers. So if you want to deploy or if you want to implement your own schema compatibility checker, so you can just implement that interface and add to this kind of configuration. Uh, as I mentioned, is one checker. The model is one checker per schema type. That means Avro has its own schema compatibility check, and Jason might have his own compatibility check, and we don't do kind of the primitive. We don't do a schema compatibility check for primitive types. The reason is there's no schema evolution for these primitive types. So the current support schema evolution is only Avro in JSON. Uh, we might be support ProBuff and in some form, but ProBuff is a bit different from Avro in JSON, so we still need to figure out what is the schema evolution story there. But at this moment is we only have compatibility check for Avro and JSON. And so this is the concept of compatibility check. But in terms of the strategy, we actually have kind of bunch of the strategy is uh, like most of people would know backward, forward, and full. And as well, I think from the naming, you probably already know always incompatible means you are allowed to produce messages with different, sorry, you are not allowed any schema evolution. So you just have one schema, no matter how you want to change the schema, any future schema changes would be disallowed. And always compatible just means I don't care about schema. I don't care about compatibility, and I want to produce as many schemas into this topic, and I would kind of program myself to use the schema information to check how we want to how application want to serialize and deserialize. So this is always compatible. And backward is it means you are allowed to delete fields within a schema or add an optional fields in a schema. So backward means if you are using a newer schema, and the newer schema is able to read the messages produced by older schema. So a newer schema need to be backward compatible with previous schema. And forward is kind of this in a revert way is the um, uh, old schema is able to kind of uh, uh, old schema is able to consume the data produced by newer schema, and that means you are able to kind of add fields and delete optional fields. Is because for newer data you can have new fields in a schema, because the old schema would be able to kind of figure out or deserialize the data that is serialized by the newer schema. That is the forward. And full is basically the combination is I'm able for I can use any schema to serialize, so to deserialize any messages serialized by any schema. So this is called full compatibility. And so this once in terms of this compatibility check, there are kind of three indicators that you need to understand. That is one, the first thing is what kind of changes are allowed. So backward is you can delete fields, add optional fields. And for forward, you can add fields but delete optional fields. And for full is basically everything should be optional, and you shouldn't change types between schemas for like the same field. And the second thing is, as I mentioned, every within the Pulsar topic, multiple schema version was maintained. So that means when you have a schema uploaded, you need to figure out two things. So you need to do exactly, you need to decide two things, whether you want to check, well, what schema you want to compare. Is it, are you comparing with the latest schema, or are you comparing all schemas? And that is into kind of one of the concept called transitive compatibility check versus non-transitive compatibility check. I have a slides later to talk a bit about that, so I will kind of skip the second column here. And the last thing is, once you apply a compatibility check for your topics, then there's an indication here is about who should be upgraded first. Um, for backward, I think it's kind of clear is you have you can upgrade consumer to have the newer schema, because the newer schema is able to deserialize the messages from old schema. And for forward, it's kind of the reverse way. You need to upgrade produce first, because the old schema is able to deserialize the messages uh, produced with newer schema. So you need to making sure producer is upgrade first with newer schema before upgrade consumer. But there's another thing you need to kind of taking special cares on the forward is you need to making sure all the messages within the same topic has been consumed by the consumers before you upgrade. Because in the forward compatibility check situation, newer consumer is not guaranteed to be able to deserialize the uh, consumers with old schema is not guaranteed to be able to consume the messages with newer messages. So you need to making sure the messages with all the old data is consumed, and that's the is consumed and also deleted, because you shouldn't do any rewind operation once you upgrade the consumer. Upgrade once you upgrade consumer, the consumer take the newer schema, and if you try to rewind to position to consume the message with old schema, then it will hit problems, because the newer schema is not guaranteed uh, to be able to deserialize the messages with the old schema. So that is the forward part, forward schema. That is the one part that you need to take care. And for full, that means every schema is compatible with the other schema. So you don't need to worry about the upgrade in rollback situation. So you can do whatever you want in any order. And the full compatibility schema check is, I believe, is the default schema compatibility check strategy if you enable the schema compatibility check. So that is the compatibility check. So yeah, I already kind of have a slides to talk about the upgrading clients. So for backward, upgrade all consumers before producing new events. And for forward, upgrade your producers to produce new schema. And make sure the data produced by old schema are not available to consumers anymore. That is important, because newer schema is not able to is not guaranteed to deserialize the messages from produced by using old schema. Then once you guarantee all the data has been kind of with old schema is are all deleted, then you can upgrade producers to consume sorry, you can net upgrade consumers. I think this is a typo. And for full is you can upgrade producer and consumer independently. And if you are using always compatible, I think you are taking the responsibility to managing the schema versions yourself. So you should be kind of taking care yourself when to upgrade the client. So that is the order of upgrading clients. Then, sorry. Then try to kind of go back to cover a bit about the transitive and non-transitive discussion. So by default, I mean, at least at the first very early stage that when we introducing schema registry, we only have backward, forward, and full. That means all the compatibility check, it only applies to the latest version. So that means uh, version 2 is able to read version 1, and version 1 is able to read version 0, but there's no guarantee that there's no guarantee version 2 is able to read version 1. So this is the backward, forward in full. But if you want to ensure version 2 is able to also read version 0, that means you need to apply a transitive compatibility check strategy. So you need to making sure once you want to add, if you want to add a new schema, the schema verification should happen on every schema, or should apply to every schema. It should not just to the latest. So in this way, you guarantee if you upgrade to using a newer schema, the newer schema is able to read all the messages produced by the old schema. So this is the full transitive. And so this is a transitive check. And I kind of strongly recommend people go with this full transitive because that would reduce a lot of problems in terms of when you want to operating the system in production, because you don't need to worry about the kind of the upgrade in rollback dependency between a producer and consumer. So that is kind of the one thing I strongly recommend. And I want to cover a bit about the version, because since we're talking about this fully sorry uh, always compatible, and as well as full transitive like compatibility check. That means you within uh, the whole life cycle of a topic, you would end up have many different versions along with the topic, and how exactly the reader would be realizing the right schema to read. So as I mentioned before, is on the producer side, when they produce a mastery, it would tag the mastery with a schema version, and the schema version is stored as a metadata bit along with the metadata, along with the messages. So when the reader read these messages, the consumer is actually maintain a schema reader cache. The schema reader cache is basically maintain, you can think about is maintain the whole schema information for different versions. So when a consumer receive a schema, and it would get a schema version from the master metadata, then the consumer would check in the schema reader cache if the schema already exists. If it's already exists, then it would use the schema information to deserialize the mastery into a right structure. So this is the kind of the happy path. Then if the schema doesn't exist, and then it would call a schema info provider, and the schema info provider would go back to broker to look up the schema by a given version, and then it will cache the schema reader within the schema reader cache. And in this way is no matter how many versions you have along with this topic, the consumer is able to correctly deserialize the message based on the schema. And this is important is if you are using always compatible strategy, that means you might end up have different uh, schema for different messages, different type of messages, and maintaining this kind of reader cache is able to kind of caching the different schema information on your reader side. So you don't need to go back to the broker to ask the information. And from application side, you can just get the master, and the master would return the schema information to you. And you can even use the schema reader cache to get the exactly schema information if you need. And so this is kind of the multi version. And what I'm talking here is more about the uh, consumer side. And this producer side, we actually also support producer, single producer instance is able to produce different type of masters. That is also support as well. And the workflow layer is very similar, is you also maintain some sort of the schema map, schema information map that is mapping the schema version to a schema info. So when application want to produce a messages with one schema, then it can just look up the schema info map and to get a right version, and then tag the messages with the um, uh, right schema version to produce. So that allows you to use one single producer to produce different type of messages, and that would be very useful for some of the event sorting applications, because you want producer to the single producers to help you maintaining ordering and as well as doing deduplications, but you also want to produce different type of masters in one single topics. So this is the kind of the schema. So hope that give you a kind of a concrete overview about the kind of the how schema works. And go back to the kind of the next topic is how this schema information can be used by when you integrate with a data processing engine or query engine. And I would kind of use a couple episodes to cover that. Is in this episode, I would use Presto as an example to kind of help people understand um, how this integration using Pulsar schema and to achieve this SQL query in data processing. And next episode, I'll probably talk about the Flink in the Flink circle because that is done in a very similar way. And at the end, um, we will but in after Flink, we'll probably talk about Spark integration as well. So I think those are kind of done in a very similar way, but the most important connection here is about the schema. And go back to kind of Presto, and I think the Presto, sorry, the Presto integration we call Pulsar SQL. It's already kind of there's already a bunch of people using that for the in production for query these event streams. So I think we also have some of the user stories about that. If you go to our website and then check our blog, I think we published one of the blog before is Zhaopin is actually using a Pulsar SQL for their search log analysis. So I think it's a very useful tool, especially if you have a data scientist, they want to issue any interact queries. Pulsar SQL is definitely one thing you should check out. And Pulsar SQL is also NC 92 compatible SQL query engine. So you can use Pulsar SQL to integrating with bunch of the BI tools like the Tableau for sure. And I think there's another project called uh, Apache Superset. You can use that to integrating with Superset as well. And go back to this is Pulsar SQL is Presto connector. So we implemented in a way is mapping Pulsar concepts to Presto and implement the Presto connector API. So then you can use Presto to kind of submit the queries. And ideally, if you already have Presto running, or if you're using any hosted Presto solution, you should be able to just use a connector to submit that. Uh, but unfortunately, I think Presto, there's kind of two things here. Is Presto was originally kind of developed in Facebook, and there's a it was called Presto DB, and I think there's a new Presto SQL foundation. It's called Presto SQL. And I think the interface, the package name was changed quite a bit. And so at the end of the day, we might end up kind of supporting both and also extract that a bit to kind of release that as a connector that so you can easily use for your existing Presto deployment. And but right now, I think we are kind of still supporting Presto DB, and we kind of bundle Presto with a given version for people to easily try it out and kind of play with it. But we might be going to do we might kind of separate Presto into Pulsar Presto into a separate repo, and so that could including bunch of the new integrations and also releasing different binaries, and that will probably happening after like 2.6.0 release. And okay, so go back here is to try to answer bunch of the question we have here is how do we convert the topic in so how do we map these topics into tables. So actually I have a cluster up running, and I'll just use that kind of as a demo, so that would be simple to understand. So actually sorry uh, so in Presto there's a concept called actually just help. So it in Presto it has its own hierarchy called catalog, and then in catalog you have schemas. Uh, just remember this schema is a very confused word. The schema in Presto you can think about it as a namespace like in Pulsar and the tables. So a catalog you can think about uh, it's a data source. Sorry, it's a collection of database, and the schema here is actually more or less close to database. And table is uh, uh, a collection table within a database. And how when we map this is for catalog, we map this into a Pulsar cluster. So you would have one catalog connecting to one Pulsar cluster, a Pulsar instance. And schemas is actually another way we call it database is actually the namespace. And the tables is actually the topics with a namespace. So this is how we map the Pulsar concept into Presto concepts. And to take a look at how it looks like is, so in Pulsar distribution, we already kind of bundle Presto together. So you can run this with SQL query. This is starting like a shell that you can kind of type SQL queries. And in the configuration side is if you take a look at the Pulsar distribution, you will find there is a directory under conf is called Presto, and that is including all the Presto informations. And so the catalog itself is actually a configuration you have to kind of config. Here is the, oh, sorry. So this is the catalog directory that is containing all the catalog definition. And if you take a look at the catalog here is it basically, it's a clusters related settings. So it basically used for telling Presto what is the connector name. And this is a kind of the Pulsar settings. What is the Pulsar broker service URL? What is the BookKeeper URL? And bunch of the default settings, and as well as some of the Pulsar authentication plugin, authentication parameters, and the if you're using offloader, then you can also config to kind of how this Presto connector can talk to different to your like tier storage. And with that being said, is the it's you can have multiple catalogs pointing to, if you have multiple Pulsar clusters, you can have multiple cat catalog. So let's just give a random name. I just copy that Pulsar catalog, call it let's call it StreamNative catalog. Sorry, I used the wrong name. So big copy, and I can edit this. Oh, I don't have the, yeah. Okay. Okay, let me see. Let me try to install Vim. So I can just change the name to StreamNative because this is a name that will be displayed in the catalog. So you don't want it to show kind of two same name. The other is just the same. So then once we have the catalog, then I will just run the circuit again, and then we can show the catalog. Actually, I think, oh, I see. I think it probably doesn't check in this way because I think it checked the type. So I probably, oh no, sorry. Let me double check. Rerun this again and show catalogs. Oh, okay. I think it's probably checking a different things, but probably the types. But anyway, just the catalog is basically you can think about it's a Pulsar instance, and within this Pulsar instance, the namespace, which is the combination of tenants and namespace, will be converted into database, which is the schema in Presto. So this would be show schemas in Pulsar. So as you can see here, it kind of having this public default, public functions, public about Pulsar system. So those are the um, namespaces that is convert into database in Presto, the schema in Presto. Then once that you can use show tables in Pulsar. So you can show what exactly is the tables that is available in Pulsar, and then you can, if you want to check, you can use describe. That I have two topics, but one topic has schema, the other topic doesn't have schema, so we can take a look at to see what a difference here. So this perf topic is generated by the perf tool, so it doesn't have any schema information. But when I describe, you can see it kind of building out kind of the list of columns, and this all this core column that has this. Sorry, I, I shouldn't copy that. So it all start with underscore underscore. That means these fields are kind of the metadata field. So it's actually generated by mapping the message metadata into the fields within a given row. And for example, like partition means the partition ID where this message is coming from, the event time, publish time, message ID, the full message ID, and sequence ID, producer name, key, and properties. So this is kind of the information. And since the message itself, it doesn't contain any this value, so any schema, so it will just convert the message payload as a value field. The value is just the binary, it's a binary, so it's a byte array. And if you want to take a look at this this table, then we can run select. So you can see here, okay, it's actually bad. Is the since it's a binary, so in Presto, it basically when you dump a binary, you just print the whole hex code. And the other stuff you can see here is the partition, event time, publish time, the message ID, and the sequence ID, and the kind of producer name. And if you want to do a simple query, then we would just count, and then it will give you the kind of the query result. So this is a topic without schema. Then let's take a look at the other one I have is the show table. Let me put the generate test. This is a topic that is coming from the data generator that is a kind of generating an Avro object. And as you can see here, it has bunch more kind of information than the kind of the previous query. And let's describe that to see what exactly it is. So as you can see here, is we still have those metadata fields. Then, but the difference here, there's no that underscore value, because the value is actually, because this topic has schema, and the schema is the Avro schema, and it's a struct. So it basically, when Presto, we do the mapping, the Presto is basically the Presto connector is converting the schema into this data field. And as you can see here, some of the fields also have this address dot street. That is because it's a nested structure. So when we do the conversion, we convert the nested structure into a kind of a flat field, a flat list of fields. So that means all the nested structure will become this address dot field name, and if you have if this is another nest structure, that would be dot the field name. So this is coming from the schema, and the comment here is, I think when we construct this is not, there's no annotation added to kind of add comment to individual fields. But for production, if you want to use Avro, the recommendation is usually just add comments for individual field, so people know exactly how this schema, how this structure is being used. So this is the kind of the Avro schema mapping into Presto. And the last thing I want to mention here is as you can see here, this is key. One of the common question I have been asked is, does Pulsar support compound key? The answer is yes. So if you use compound key, or if you put schema on keys, then in Presto, we'll convert this into underscore key dot uh, fields within that key schema. So if say I kind of having the same structure in key, and when we describe this table, then it would be underscore key dot first name, key dot middle name, key dot last name. So you will still able to access individual fields within that key schema. So that is the kind of the schema mapping. And originally I was kind of trying to cover a bit how does Presto query data, but since we are kind of running out of time here, and I will probably have a dedicated session to talk deep dive into Presto schema, and to showcase how we can use Presto schema, and how you can tune the Presto schema, but how you can tune Presto queries in order to kind of accelerate the queries, and how Presto interact with TS storage, and that would be a good episode for in the future. And I think since we are kind of running out of time, and hope this session is useful for you to understand a bit more about a schema, and you can start playing with schema, and as well as playing with Presto, and uh, that I try to ramp up here. That would be all for today. And since we are going to have a training, and the Pulsar Summit is coming in 2 weeks, we are not going to have TGIP for the coming 2 weeks. The next episode would be kind of 3 weeks, probably the week after Summit. In next episode, I'm going to cover a bit. We'll continue a bit on the schema side, and I will talk a bit about the Flink in Pulsar integration, especially around the schema side. And that's all for today. And if you like our kind of TGI Pulsar live stream, subscribe to our YouTube channel and give a star. And and I will see you in next episode in 3 weeks. And hopefully, I will also see you in Pulsar Summit. And thank you everyone for coming to TGI Pulsar, and good afternoon, good evening, good happy weekend. Bye bye.